Hi everyone, welcome to 8th grade math. Today we're looking at Module 2, Lesson 1, Why Move Things Around. So before we get started, I want to remind you of what your notebook should look like. On the left-hand side page, you want your 4 categories, your learning target, mathematical practices, play pause it practice, and reflection. Your learning target should restate what today's objective is, right? So if we're looking at why we move things around, think about what that means mathematically. Mathematical practices you have listed in your notebook. I want you to find examples of how you are using mathematical practice number 2 and number 4. Your play pause it practice are your quiz questions that appear throughout the video. So make sure you're not only answering them on the computer, but you're showing your work in your notebook and circling your final answer. And then lastly, you have your reflection, which should just tell me what you learned. On the right-hand side of your page should be all the notes that I give you throughout the video, so make sure you pay close attention and get everything written down. Don't forget, this is your lesson. You're in control. You don't have to wait for anybody, and you don't have to worry about slowing anybody else down. So utilize the pause, rewind, and play features of the video to get your best notes on your paper, and don't forget to show your work. You may want to watch the video more than once, you may want to pause frequently, you may want to fast forward. It's totally up to you. Make sure that you're taking advantage of the situation, that you have a one-on-one lesson. Hi everyone, today we're covering Module 2, Lesson 1, which is titled Why Move Things Around. And we're talking about moving things around on a geometric plane. That means kind of on a graph. And the different things that we are going to move around are, ideas that we've talked about before, but we should probably do a vocabulary refresher before we start. So the 4 terms I want to go over are segment, quadrilateral, vector, and angle. Now don't forget to pause the video if you need to get a chance to write this down. A line segment is a section of a line that is bounded by 2 endpoints. So remember, a line goes on forever. A segment is a piece of that line with 2 endpoints. A vector is a section of a line with 1 endpoint. So I have a line, it goes on forever, but in one direction, it's pointed specifically. A quadrilateral is a 2-dimensional shape with 4 sides. So that can be a square, a rectangle, a trapezoid, a diamond, parallelogram, etc. And an angle is a measure of turning between 2 vectors, and they share an endpoint. So remember, a vector only has 1 endpoint, so if they share it, then they both have the same thing. So these are some of the geometric shapes, figures that we're going to use to move around. So what's different about the concept of transformation is we're going to move around these different things on our coordinate grid without any measuring tools. So that means no rulers, no compasses, none of those things to really help us to decide whether or not the shape that we're moving is following the laws of a transformation. So we can ask different questions like, how do I know if 2 line segments are the same length? Now, normally you would take out a ruler and measure, but we can use properties of transformations to move one of those segments on top of the other and check if they're the same length without using a ruler or compass or any of those things. Another question you might ask is, how do I know if opposite sides of a rectangle are the same length? Now, this is something that we learned a long time ago in elementary school, that the opposite sides of the rectangle are the same length. But how do I know for sure without using a ruler? We can also think of things like, do 2 angles have the same measure? I can even check if using parallel lines are the angles the same measure. So what's really great is that we can answer all of these questions using a transformation. All we need to do is make sure that we are keeping the properties of a transformation in mind when we're working with them. In order to do that, just like in any area of math, we need to use the proper notation. Notation is mathematical symbols like a plus sign or a minus sign. Some of us have studied exponents where you have a big number and then a little number up to the top right-hand corner. Notation is extremely important in math because it prevents us from having to write full sentences to describe what we're calculating. It's almost like a language of its own. So again, mathematical notation is the proper symbols and language to talk about or to talk like a mathematician. The first notation we need when we're talking about transformations is a point P. Anytime we have a point, we want to label it A, B, C, D, whatever letter we come up with, but we want to make sure that it has a label because when we transform that point, we call it the function of P or f of P. That means that we are doing something to that point P to change it. The result of the function of P is called P prime. So you have a point P, you do something to it, and you get what's called P prime. It's the same point in a new location. So transformation, it transforms what we have. The final idea is that transformations move math objects around without changing the shape or distance. So we can move all sorts of things around a plane without compromising measurements that we've already taken. It's a really great tool to use in math class.